We are going to go through our last lesson of chapter 2, which is solving absolute value inequalities. So you're going to see in chapter 1, we did solving absolute value equations. Now chapter 2 is all about inequalities. Now we're going to solve absolute value inequalities, which is very similar to solving an absolute value equation. So our core concept here, okay, when we solved absolute value equations, you would have remembered that we had two cases. Remember, we had case 1 and case 2. That same concept is going to follow when we're solving absolute value inequalities. There's going to be two different types, because when we had those compound inequalities that we just saw in the last section, remember that we had and compound inequalities and or compound inequalities. That's going to hold true when we're dealing with these absolute value inequalities. So when you have the absolute value is less than, we're going to create a compound inequality with the word and. So you want to think of it as less than, okay? So when we have a less than symbol as a part of our absolute value inequality, we're going to be dealing with a less than or an and compound inequality that we're going to be dealing with. When we have the greater than symbol for our absolute value inequalities, we're going to be dealing with a or compound inequality. So it's all about what that inequality symbol is to determine the type of compound inequality that you're going to be dealing with. So you want to think less than, it's going to be an and compound inequality. Great or, when we have a greater than symbol or greater than or equal to, it's going to be an or compound inequality. When we're dealing with these compound inequalities or absolute value inequalities, we're going to write our two separate cases, and then we're going to go ahead and solve like we normally would. So let's go through some examples. Here are our first two examples, okay? We have the absolute value of x plus 7 is less than or equal to 2. So if we notice here, we have a less than or less than symbol, but we think of it as less than. So I know this is going to be an and compound inequality. So I'm going to go ahead and I'm going to write my two cases out, just like I did when I had absolute value equations. So I'm going to have case 1, which is going to be x plus 7 is less than or equal to 2. And now I have to write my second case. And in my second case, I have to remember to both change it to a negative and flip the sign. So I'm going to have x plus 7 is greater than or equal to negative 2. Notice I had a sign flip of my inequality sign, and I made this a negative as well. Don't forget to do both of those parts. Now let's go ahead and let's solve our equation out. So subtract 2, x plus 7 is less than or equal to, no, sorry, not subtract 2. Get out of here. Subtract the 7 from both sides. You're going to get x is less than or equal to negative 5. And subtract 7, x is greater than or equal to negative 9. We could leave it like this, but it is an and inequality, so we want to smash it all together. Our x goes in the middle. We know x is less than or equal to negative 5. We also know that x is greater than or equal to negative 9, so we would prefer that you write it this way. It's an and inequality, so I know I'm going to shade in the middle. Negative 9 is here. Negative 5 is here. Close circle at both. Shade in between. And there's our solution there. Now let's look at the second example. The second example says the absolute value of 8x minus 11 is less than or equal to 0. Or sorry, less than 0. Let's think about absolute value for a second. We remember, hopefully, that absolute value must be greater than or equal to 0. So if I look right here and I say to myself, wait a second, can the absolute value of something ever be less than 0? No. Absolute value can never be less than 0. Okay? It has to be greater than or equal to 0. So I don't even need to go through the rest of this problem. I know the answer right here is just going to be no solution because absolute value must be greater than or equal to 0. So always recognize those same things. We saw it when we dealt with absolute value equations. We had those cases where there was no solution. Those can appear here as well. So you have to recognize and remember in the back of your head, what does absolute value tell me? And absolute value has to be greater than or equal to 0. All right? To try these, we'll go through in class. Let's look at some more examples here. We're going to look at examples A and example C. So now if I look at my inequality symbols, I can see I'm dealing with greater than symbols here. So remember, greater than we think of as great or. So I know I'm going to be dealing with or compound inequalities when I'm solving each of these out. So the first one, pretty simple case here. Let's write our two cases. Case 1 is just as I see it. C minus 1 is greater than or equal to 5. Case 2, C minus 1, flip the sign, less than or equal to, change the sign, negative 5. Great or, we have an or compound inequality. Let's solve it out. Add the 1, add the 1. C is greater than or equal to 6. Or, add the 1, add the 1. C is less than or equal to negative 4. Or compound inequalities, we don't smash together. We leave them with the word or in between. And we're shading on the outside here. So let's draw on our number line. We've got negative 4 down here. We've got positive 6 over here. We're going to have closed circles at both of them. And we're going to shade on the outsides because it's an or compound inequality. Letter B is another one of our special cases. Think back to what I said on the previous slide. Absolute value must be greater than or equal to 0. So no matter what value that I plug in, the absolute value is always going to be greater than or equal to negative 2 because the absolute value has to be positive. So this would be a case where my answer is all real numbers or infinitely many solutions. Because it's one of our special cases again. So when you're dealing with absolute value inequalities and you see that there's somehow a negative involved or something like that, that's your clue like, wait, I might be in one of my special cases here. And in this case, our answer would be all real numbers, infinitely many solution. Everything is an answer here for this one. Last example that we're going to see in the video is letter C. Now, letter C is a little bit more complicated because my absolute value is not isolated yet. So just like we saw when we solved absolute value equations, we have to start by isolating the absolute value. So I'm going to start by subtracting 1. Don't write your cases until you isolate the absolute value. That's a common error. So now I have 4 times the absolute value of 2x minus 5 is greater than 20. Divide by 4. I've got the absolute value of 2x minus 5 is greater than 5. Now my absolute value has been isolated. Now I can write my two cases. So I'm going to have case 1, just as I see it. 2x minus 5 is greater than 5. This is a great or, so it's going to be an or symbol. Case 2, 2x minus 5 is less than, flip the sign, change the sign, negative 5. Let's solve both of these out. Add 5, add 5. 2x is greater than 10, and divide by 2. You're going to get x is greater than 5. Or add 5, add 5. 2x is less than 0. That's okay, I can do that. We can have 0 over 2, or x is less than 0. There's my solution. Let's graph it over here on the left. Or compound inequality, we're going to shade on the outside regions here. Open circle at both of these. Less than 0, shade left. Or greater than 5, open circle at 5, and shade right. And there's my graph representing this. Okay, so there's a lot in this section. We'll do a lot of practice in class. Key things to take away here when we're dealing with these types of problems. We've got our two types of compound inequalities that we're going to be writing with absolute value inequalities. We've got the less than, we're going to have an and, less than, great or. The only other thing to make note of is worry about your special cases. Okay? When we have our special cases here, remember we have our all real numbers or infinitely many solutions, and then we have our no solution cases here. When we have something like the absolute value is greater than a negative, we've got our case where we have all real numbers. When we have something like the absolute value is less than 0 or is a negative number, that's the cases when we have no solution there. Remember, don't forget when you're writing your two cases, for your second case, make sure that you're flipping the inequality sign and changing the sign from a positive to a negative when we're solving it out. Good luck. See you in class.